Right, so then we've got the maximum demand of the installation. Now you can calculate this, and it might be more important to do that, if you've got a commercial or industrial premises. But again, in the interest of time, when we're doing domestic stuff, generally take that value either from the size of the fuse or the maximum current rating of the main isolator that you've got in your consumer unit, which is usually 100 amps. We've then got the protective measures against electric shock. Again, fairly standard in domestics would be ADS, which is automatic disconnection of supply. All that means is, in the event of a fault in your consumer unit, you'll have a range of circuit breakers, most likely, or RCBOs or RCDs or fuses. And essentially what happens then, in the event of a fault, the fuse will break or the MCB will operate and it will just disconnect the supply automatically, hence automatic disconnection of supply. We've got the type of main switch in your board. More often than not, again, it's a fairly standard double pole switch. Yeah, usually it's a red double pole switch. We have then got the size of the supply conductors. Now we note this down, and more often than not, again, this is 25 millimeters squared. So your line and your neutral coming from your electricity meter into your consumer unit, the size of those cables will be 25 millimeters squared. Now we check this because, again, just going back to our on-site guide, and these numbers are in the main wiring regs as well. If we look at a 25 millimeters squared single core cable, which is what it is, that can carry over 100 amps. And so the cable is protected by the main cutout fuse if it's rated at 100 amps. The thicker the cable, the more current can flow in the cable without the cable overheating. The skinnier the cable, the less current can flow in that before the cable starts to get warm and potentially overheat. So the fact that the supply conductors are 25 millimeters squared means that they will be protected by a 100 amp fuse. In some older installations, the supply conductors might be 16 millimeters squared. Then if the main cutout fuse is 100 amps, it might be that the cable is no longer going to be protected, or it wouldn't be protected by a 100 amp fuse. The 100 amp fuse would allow too much current to flow, and those cables supplying your board might overheat. So that's why we note that down, and we just need to double check that against the size of the fuse. We also check the size of the main earth coming into the consumer unit. It needs to be 16 millimeters squared. If it's any smaller than that, we need to investigate as to why that is. And the bonding conductors that we talked about before, which connect the other metallic services in your property, gas, oil, etc., etc., back to the consumer unit, they need to be 10 millimeters squared. In older installations, they might be 6 millimeters squared, in which case that needs upgrading and needs looking into. So we just note all these values down and just check them against what they should be. Next up is our list of inspections that we carry out. Now, some of these are just purely an inspection, like this, visual inspection, like all the intake equipment, so the service cable, so the cable that comes into your property that actually supplies the property, and the service head that's got the fuse in, the earthing arrangement, etc., etc. We just do a visual inspection. All of that stuff, all of the supply, the intake equipment, that is the responsibility of the network operator to maintain that and come and fix any problems with that. So if there are any problems from that part of the installation, we advise you to get in touch with the network operator, and they will come and sort out those problems free of charge. Thereafter, and I'm not going to go through all these, you can see there's a huge list of inspections. Some of these are informed by taking things to bits and having a look behind and having a look at the cables and what have you. Some of these ticks or codes are informed by the test results that we obtain when we're actually testing rather than inspecting. You can see at the end of each point there is a regulation code. So if we really wanted to, let's say for argument's sake, presence of a main linked switch, so the red switch that we talked about before, we can go into the regulations. So does it have presence of a linked main switch in the consumer unit? We've got a regulation number there. So this is under isolation and switching. A main link switch or linked circuit breaker should be provided as near as practicable to the origin of every installation as a means of switching the supply on load, which means with current flowing in the installation, and as a means of isolation. So it is a requirement there. It's referenced on here, and so you see that every inspection that we carried out has got a relevant regulation. Following those regulations means that the installation adheres to legislation. So you can see that in this case there's a lot of ticks. There's some that aren't not applicable, so there was no isolator at the origin where the supply comes into the building, so not applicable, that one. There's no earth electrode in this instance because we're using the main earth that the network operator has provided. And anywhere where you see a tick, that's all good. Anywhere where there's a C2, C3 or a further investigation will get pulled through on the software to this summary of observations which we talked about before. So it's duplicate information. You see we've got the C3 code there, correct identification of circuit details. There wasn't any, so that needs to be provided and upgraded. That is then pulled through here. Yeah, correct identification of circuit details. Yeah, so that's just duplicate information.